All right, let's jump straight into this explainer and unravel one of the most architecturally impactful patterns in modern systems, the Mediator Design Pattern. Look, if you've ever dealt with a tangled, messy web of code or microservices that feels completely impossible to untangle, you are absolutely in the right place.
To really grasp why this pattern even exists in the first place, think about a busy airport. Imagine you have 20 airplanes up in the sky all flying simultaneously. Now imagine if there was no control tower down on the ground. Every single pilot would have to communicate directly, peer-to-peer, with every other pilot. They'd be shouting over the radio, "Hey, I'm landing on runway 3. Are you landing on runway 3? Wait, what about you?" 20 aircraft talking directly to 20 others creates exactly 190 simultaneous, chaotic communication channels. The chaos would be, well, absolutely catastrophic. But notice how the control tower instantly solves this whole mess. That n-squared peer-to-peer chaos is immediately converted into single, completely manageable connections. Each pilot talks only to the tower, and the tower coordinates everything. It's actually incredibly similar to those old-school telephone switchboard operators routing calls. They take the entire burden of connection away from the individual endpoints. And that brings us right to the formal definition. The mediator pattern is simply an object that encapsulates how a set of objects interact. By making one central coordinator the single point of contact, your components no longer need to explicitly refer to each other. They just talk to the mediator, and the mediator decides who else needs to know about it. It really is the ultimate tool for promoting loose coupling in your systems. Okay, real quick, here's our roadmap for this explainer. First, we'll look at the chaos of tight coupling. Next, a code-level aha moment. Then, mediator versus observer. After that, we'll scale it up to architectural mediators. And finally, we'll wrap with trade-offs and best practices. All right, let's get into part one, the chaos of tight coupling. Let's translate that airport analogy directly to your software. Say you have a microservices architecture. Service A calls service B, which calls service C, which then calls service D. But wait, suddenly service D needs to call service A back. You have just accidentally created a terrifying web of circular dependencies. And what happens when you add service E and it needs to talk to A, B, and C? Every single new service multiplies the connections, creating this tangled star pattern of chaos. This is the M times N coupling explosion, and let me tell you, it makes systems incredibly brittle. Moving right along to section 2, the code level aha moment. We really need to make this visceral, so imagine building a basic calculator app. The wrong way to do this means every single number type is directly wired to every other type to perform math. If you want to add the number 10, you have to go in and rewire every single existing component just to accommodate it. It's a literal maintenance nightmare. But the mediator way? It uses a single central sum function. The number 1 no longer directly connects to the number 2. If you add 10, you only connect it to that central sum function. Your individual components remain completely independent and blissfully ignorant of one another. Which brings us to section 3, the mediator versus the observer pattern. Look, this is a classic interview question, so we need to make the distinction absolutely crisp. The crucial difference is in the routing and the logic. The mediator is like air traffic control. It handles bidirectional, complex routing and actively makes orchestrating decisions. The observer, on the other hand, it's basically a guy with a megaphone. It is a unidirectional broadcast. The publisher blindly notifies everyone listening without knowing or caring who they are. So rule of thumb, if your central coordinator uses logic to decide who gets notified and why, it's a mediator. If it just blindly shouts out an event to anyone who will listen, it's an observer. Next up, section 4, scaling up to architectural mediators. Let's zoom out from the code for a second and look at the actual systems you interact with daily. Because honestly, you've been using the mediator pattern at scale this whole time. Think about message brokers like Kafka and RabbitMQ. They sit right between producers and consumers. The services don't know about each other, they only know the broker. How about API gateways like AWS API Gateway, Kong, or Nginx? They take all external requests and route them appropriately. They are the ultimate digital switchboard operators. And a service mesh, like Istio, uses a sidecar proxy to mediate literally all service-to-service communication. These are all mediators operating at an infrastructure scale. And finally, section 5, trade-offs and best practices. Let's talk about the massive advantage first. The mediator's single point of contact is an absolute superpower for observability because every single interaction, every retry, and every rate limit passes through one central point. They all become instantly visible. You can enforce authentication, authorization, and circuit breaking in exactly one place, rather than scattering it across 50 different microservices. However, we have to talk about the danger here, because centralization is powerful, but it's also dangerous. If you leave it unconstrained and use it for all your application routing, your mediator becomes a massive bottleneck. We call this the God-object anti-pattern. When a central coordinator knows too much and does too much, it completely violates the single responsibility principle. Suddenly, your elegant solution turns into a total debugging nightmare because the complex logic of your entire system is jammed into one bloated component.
So how do we actually use it correctly? You want to deploy the Mediator specifically when you have complex workflows. It is perfect for complex UI event coordination where multiple widgets are affecting each other. It's also the absolute standard for chat and messaging systems. Think about it. Users don't connect peer-to-peer to chat. They talk to a central chat room abstraction. Use it for multi-step microservice workflows or, honestly, anything resembling air traffic control and distributed transaction coordination. On the flip side, when do you avoid it? Do not use the Mediator for simple fan-out notifications. Use the observer pattern for that. Don't use it if you only have two interacting components. Just let them talk directly to each other. Keep it simple. Definitely do not use it as a global event bus for literally everything in your app, or you'll create a system where cause and effect are totally invisible. And crucially, remember that every interaction through a mediator adds a function call in direction. So for performance-critical hot paths that need millions of operations per second, direct coupling is actually much, much faster.
Okay, so we've covered the chaos of n-squared coupling, the elegance of the central coordinator, and the profound impact this pattern has on the infrastructure we rely on every single day. So I want to leave you with a provocative question. Take a really close look at your own code bases and distributed systems after this explainer. Where is a hidden M times N communication web lurking in your architecture right now? See if you can spot the chaos before it crashes, and ask yourself, is it time to build a control tower? Thanks for joining me on The Explainer.